Hello and welcome everybody to our How to Repair Pendulum Clocks 41st of 50 Open Clock Clubs. And so a super special welcome to anybody who is new. We've got somebody in the car today, which is cool. Yeah, so my name is Matthew Reed and we run a little enterprise called How to Repair Pendulum Clocks, which began with our book that we wrote to get people off the starting line, and the whole thing kind of grew from there. And one of the things that we did was to start this series of events in lockdown to support people. Another thing we did was to start a Facebook group, which is just about to exceed or reach 1,000 members. So massive thank you to everybody who's joined up, and particularly to those people who support us by showing their work in progress projects. And that's really, I think, it doesn't really show any sign of slowing down, which is quite scary, really. But that, for me, has become the one kind of defining characteristic, because I know there are a lot of Facebook groups for clock repair, and there's Jane, and you know, we would need to do something that's unique in a way. And I always remember what it's like when you begin. It's quite a kind of tough environment to get in with all the technology and the tools and the names of things. So that's where I'm going to continue to focus. And I think the best way we can all help everybody is obviously by answering questions, which we've been doing today, been doing all week. But primarily, when you've got a pendulum clock project on the bench, please, if you can, just take a few minutes more. If you see something that's kind of interesting or unusual or a tricky repair, just think, I know what, I'll just take 5 more minutes. I'll take some photographs or a little video and I'll stick it up on the Facebook group, because that really helps us massively. So anyway, that's my Facebook rant over. Thank you to Team Open Clock Club who's here. So if you wouldn't mind saying hello and where you're from and what's the weather like where you are, because we are now an international event. There's no two ways about it. So remember, as always, if you want to remain anonymous, then please keep your camera turned off. Otherwise, let's see you and also join in the live chat, because the live chat on these events is really important. So a little recap from the week. Yeah, loads of stuff going on Facebook. On Thursday, we came back from our live stream holiday. We hadn't had an actual holiday per se, but we've just been doing other things. And not talking about this today, because this is our live stream clock, but we got into Ingram, or Ingraham, however it's pronounced, clock, which is a little bit outside my comfort zone, because although I've been fixing clocks for 30 years or something, I've been breaking them for 35 years and fixing them for about 3. But anyway, that's the kind of a learning curve. I don't know masses about American clocks, so this is very much a kind of joint effort. So on Thursday night, we got the clock out of its case, did some vacuuming up, and then began to look at the mechanism, which to many of you people out there, this will be very much sort of bread and butter stuff. So some quite cool things here. One thing, and we talked about this on Thursday, you can find the recording of that over on our YouTube channel. But one of the things we talked about was the progression from beginner. So what was the first clock you ever fixed? And without wasting the time here tonight, we thought a lot about this and decided on our single train Enfield mantle clock, as you know, for a good place to begin. But of course, and I think particularly if you're in the States, there are a lot of American-made clocks, and inevitably people get to fix these either right at the beginning or pretty early on in their clock fixing careers. I don't know what I presume there are professional programs and programs run by your professional organizations. It'd be interesting to know what they suggest you start on. So these 2-train American clocks are really cool. This one's got a deadbeat escapement and in really nice sort of well-preserved condition, just like I like them. and very interesting machine, very cleverly designed count wheel striking here, so you can see the count wheel. And for me, the big challenge here with a clock like this is when you reassemble it, getting the phase relationship of the striking work right, which we'll go through on the live stream. But the big thing, of course, is getting the springs or removing and replacing the mainsprings, putting them back in again safely. Because in our book, for the beginner, what we say for a going barrel clock is it's a reasonable adjustment, at least for your first project, to leave the spring in the barrel and clean the bearings. Obviously, you don't want to be doing that as you progress, but just to get you off the starting line. And you can't do that with these clocks. So we've been talking on Facebook about whether you use a zip tie to hold the springs, or I thought a strap, a toe strap from a push bike, or a clamp, you know, a C clamp. And I'm going to make some and do some experiments anyway. But so if you've got any thoughts, what's your preferred method of retaining these springs when you take the clock apart? Anyway, that's Thursday. We'll be back next Thursday with another live stream. So that's quite cool. Let's look somewhere. Put the movement. No horizontal surface. We got there with a long case clock. No, it said I've been. Presumably, I'm not muted because people would say, "Okay."
I can only see. It says Matthew Reed has started screen sharing.
Right. Okay, just a little technology issue here. Well, I can see me and all our lovely participants and my camera, which is live.
Oh, Wolf, you can see the bench.
Yeah.
Right. Okay, we're fine. It must be just me. Yeah.
Right. Okay.
Yeah.
Right. Good. Okay. So for the past few weeks, we have been working on Fusee-driven clocks. These are predominantly European clocks, not necessarily, but predominantly that have got a device called a Fusee for evening out the power of the mainspring. So the clock we were working on, took it apart, cleaned it, put it back together, everything tickety-boo, but the suspension spring was broken. So last week, started making a new one. Let's just zoom in a little bit. Here we are, and see if it'll focus. Yeah. So started making a new one out of a bit of spring steel strip, and you can see we made a top, the top block here out of a bit of brass CZ108, which I bent over, and then during the week I filed it up and tidied it up a little bit. So we're kind of ready to go. Now, let me just get the back cock. So this device is called the back cock. And somebody, I think on the Facebook said it's called a bridge, which, I mean, you know, who knows about the name of things? There is no proper name of things, but this is generally referred to as the back cock. But I get why you would want to call it a bridge, like an hour bridge, because it's got two feet under here, two positions it's screwed down. And I think the reason it's called the back cock is on earlier clocks, 17th and 16th century stuff. Often the back, what we now call the back cock, was in fact just a single sort of thing, like a finger, like you find on a minute wheel or something, any road. So here's our suspension support. We made this brass chops, our top block. So it's a really good fit in there. You can see it holds it by itself. So it's a little bit tight still, but we'll deal with that right at the end. And I went on last week quite a lot about the pin that goes across here. Now I lost the pin. So what I said was, don't put a taper pin in there, because there's the thing will tend to tip across at one side. Maybe it won't matter too much here, but it's much nicer to put a parallel pin in there, or a near parallel pin. So you could just take a tapered pin, you know, like a regular clock pin. But what I'm going to do is get a bit of blued steel. Here we've got blued pivot steel, and that just hopefully doesn't fit in the hole. Yeah, it's a bit big to go in the hole. I'm just going to, you can't file this material, or you can't file it easily anyway. So we need to anneal it a little bit. So we're going to heat it up to cherry red, let it cool, and then it'll be just soft enough. Good thing about this material is that when you do that annealing, it doesn't go dead soft straight away. and the problem with a tapered pin is that they always end up being a bit kind of squidgy, and you can never really sort of get them to be a good fit. So I'm just going to do that. A little bit of gas. And out. There we go. So that's just heated it. I'll allow it to cool there while I get the vise.
Is that a new torch, Matthew? New gas torch?
No, the new gas torch has been pressed into domestic service. I can't really say a lot more than that, but it's presently not available. So the minute it landed, this is a Sievert gas torch, because I'm always complaining about these DIY torches, which they're all right, they're okay, but the problem is that the flames tend to kind of gush and blow themselves out, and they're a bit of a pain, but they're cool for this kind of domestic environment. So we invested in a Sievert professional gas torch with a propane bottle, and the second it came through the door, it was seconded for a different project, not horological related. So regrettably not yet anyway. Right, I'll just get the vise.
Franklin says, why is the shape of the bottom side of the suspension spring chamfered?
Why is it curved?
Yes, it wasn't last week.
No, I just it was just put the so Franklin asks, good question as always, why is this curved here? Get it to focus. Why is it curved? No reason really. I mean, it just looks smart. It was folded over last week, so it was just kind of rough, and I just filed it to a curve. It could be flat. It doesn't make a whole lot of difference when the spring bends. This little tiny bit of extra length here, as long as it's symmetrical, it's fine. I just thought it looked smart, that was all. So I just fancy, nothing more than that, no technical.
You meant the tip of the steel spring itself?
Here? Down the bottom? That bit? Oh, because I've been experimenting. Believe it or not, I do actually practice for these events sometimes. So when I'm a bit nervous, I have a little test. I think is that what it means? I'm going to cut that bit off in a minute.
Yes.
Yeah, I'm going to cut it off. It's just I was just testing, because I'm going to actually taper the spring. I was still thinking, shall I, shan't I? And I've just said, well, now I'm stuck, so I have to do. So anyway. So, looking for a filing block, this will do. Just zoom out a wee bit. So I've got a bit of boxwood here, and I'll put the pin in a pin chuck. Put the wire in a pin chuck, should I say. There we go, that's in the pin chuck. Now, even though the steel's been let down by annealing, you can't kind of go crazy at this steel. It sort of holds its toughness. So if you start filing very quickly with it, it'll just blunt your file. So file dead slow. So in our filing block, just make a little notch like that. And then I don't think it needs to be. That's probably why we're having the technical difficulties, because my mouse is joining in. There you go. So let's just check. First thing I'll do is I'll just put a bit of a, I don't know if you can hear that or not through the microphone, but it still sounds quite hard. Poor old file, anyway. So I'm just going to put a little bit of a taper on it. This seems like a faff, but like most of these things, it's kind of a principle, really. There are, if you get working on things like heavier pendulums for like regulators and stuff like that, they've often got pins in, and you don't want a soft iron taper pin in there because of the mass of the pendulum, a big sort of grid iron or mercury pendulum. So it's a good idea to have this in the back of your mind. If you can't find blue pivot steel, you can always use piano wire, which comes in a obviously massive range of sizes. It's really useful. Just much nicer sort of result. There we are. So we're getting down to size now. You can see it's kind of holding on there, so a little bit less tapered. I just want to get it to the point where it sticks in the hole, obviously.
What note do you want to strike when the taper pin?
With a piano wire?
Yeah.
Well, I don't know. That's a good question for people who ask those kinds of questions. So Wolfie, there's a bit of it's not even homework. You have to got to do this now. So it's 1.25 millimeters diameter. So on your piano forte, what note do you use 1.25 millimeter diameter wire on? Yeah. That'll serve you right for asking questions. There we are. So all good, we're done. Obviously, I'll tidy the ends up and cut it to length, but we don't need to deal with that yet. In fact, our resident pianist must have heard us. She's just rumbling back upstairs, so we can ask her what her favourite note is. So got the old cutters. Let's just trim that off there. Cool. Okay. So this I'm going to tidy up. Might put it in a watchmaker's lathe. Probably won't get a chance today to do that, but any road. Okay, so we've got our spring. I've obviously made it over length. I've been testing here, punching holes in it. So the question now is, how long is the spring? And we talked about this last week, that there are quite a few clues you can take. One of them is, of course, when the pendulum bob looks in a reasonable position, as in the rating nut isn't right down the bottom, the rating nut isn't right up the top, somewhere in the middle. We also noted that this pendulum bob has got a scratch above it where somebody's taken it apart to remember where it was, which appears to be kind of in the middle, so that's quite cool. And then our other clue is obviously the slot in which the pallet, the crutch or leader pin sits. You might reason that the obvious place for that is halfway down the slot. Doesn't want to be obviously up here near the top, doesn't want to be down here. And that will give us give us a rough suspension spring length. Obviously, if we make it length X and it's too long, we can always shorten it. So bear that in mind. However, when you shorten it, of course, you have to at least shorten it by the diameter of that hole plus a safe bit. So you're going to be probably cutting off at least 1/8 of an inch every time you shorten it. Right, so let's look at our clock movement and see what that says in terms of spring length. Put my gloves back on. The clock movement is actually still on the test stand, so we'll have to liberate it from that. Get rid of that. So here's our movement on its homemade test stand, which we all know and love. Not much room on here. And I'm just going to get but I'm just going to get it off the false plate. Don't want to take the wrong pins out. That would be a bit of a disaster. There we go. So let's just pop that out of the way for the time being. Okay, now, so most of you have seen this before. It's just have a little whiz round, zoom out. So it's actually probably very late 19th century. I thought originally it was early 20th century, but there's some evidence on the case that tells me that it's pre-World War I. So it's, you know, late 19th, early 20th century, Fusee clock, single train. We've washed it, taken it all apart, cleaned it, taken the spring out of the barrel. A couple of weeks ago, we put the Fusee chain back on, and I've wound it fully to check that it actually is going to go onto the Fusee. Haven't bothered letting it run down. I'm just going to do that as part of the testing. So if we just pop it down like that so you can see it, and put our back cock on. Now the back cock steady pinned here, which is, let's put it down a bit so you can see. The back cock is steady pinned. If you have a clock like this and the steady pins have been knocked out, and then the whole thing's been moved down, then people sometimes do that to reduce internal drop on the escapement. So it's, you've got that question, do I kind of put it back in its original position? We've discussed that before about making up the pallet faces with new material. So let's just pop the crutch in there and the pallets. We have oiled the clock, but not the back plate. So the whole front plate is oiled and so on. But what I'm interested in is here, I'll just take the pendulum bob off. Comme ça. Don't need that in the way. Is that when it's in the middle, there is a wear mark in here. I just want to remind myself where it is. Okay, it's a little bit above the center. I probably will go for it in the center, just to kind of as a test, really. So get our spring. I'm gonna have to take that pin out, pop the spring in there. Maybe I should put the back cock screws in, but there we go. So can you kind of see what I'm doing here? I've just move it down a little bit more and warm up the camera. It's a bit underexposed, isn't it? It's grey paper. So what I've done is I've put the spring in its final resting position, put the pendulum on here halfway, and then I'm just going to mark the spring where the top of the pendulum comes. Now, you will know or remember that I'm not a fan of marking clock components with a Sharpie pen because the pen does actually affect the surface of material. No problem with new making, there's a distinction here, but I try and avoid as much as possible putting a Sharpie pen on the actual old clock part. So this is new, so I don't mind. When you're doing your bushing and you maybe want to say that bush, you've done your depth thing, needs a bush and it's pushed in this direction, then just make a note in your daybook or photocopy, if you've got access to a photocopy, or scan the plate and then just use that. Okay.
Dave, I've just got a question.
Yeah.
What happens if the suspension spring is shorter than what it should be?
If I've made it too short, you mean when I'm making a new one?
Could be. Right.
Well, if I've got to make another one. Just, but however, remember two good points there. One is that I will actually rivet this at the top, but the pin in here is not going to be riveted. Do you remember when we took the pin out and it was a pain and you've got to drill it? Don't rivet that pin. You can get it out and shorten it. If I make this and it's too short, which is kind of unlikely, but let's just say it was, you've had it. You have to make a new pin because you have to make a new spring. But actually, if you think about it, we've done all the difficult bit. Making a new bit of spring wouldn't be difficult. It's just two punched holes. Right. All right.
The gauge of the piano wire doesn't affect the note.
It's the tension.
With length.
Right, and the tension. Oh, okay, cool.
And your wire is closest to standard wire gauge 0.0048.
thank you. That's really useful information. Right. So it's the length and the, I suppose, yeah, harmonic motion comes into that. The length and tension of the spring, not the gauge per se.
So Dave actually says again, what happens when it's too short?
Oh, what happens when it's too short? The clock gains, and you can't. You would move the rating note here. Sorry, you'd move the rating note. Obviously, I haven't got the swinger on the bottom. You move it down and down and down and down and down and get to that point, and you can't regulate it anymore. You've had it. And you get a double whammy with the spring being too short. As we said last week, it's not only the effective length of the pendulum, but it's the fact that when you shorten a spring, there's a cube law in relation to the restoring force. So not only is the effective length of the pendulum shorter, but also there's a greater spring force. So a little bit of difference makes a lot in the timekeeping, I think. So yeah, you just regulate it. You get to the bottom of the rating thread, you've had it. You've got to make a new spring. That's in the middle. I'm gonna have to stop talking and actually do it. So I'll put a little mark on the spring there. Yeah, you can see that. So now I need to shorten it. So let's just figure out how much actually goes inside the slot of the pendulum. Right, it's about, I'll tell you what, break the habit of a lifetime and actually measure it rather than guessing. So it's about a 16th down from the top, so it's not far. Let's see what that is in metric. Yeah, it's about 2 mil, that's all. These, I've mentioned this many, many times, but these Mitu Toyo rulers, they're quite a bit more than like, you know, your sort of regular steel rule, but they're absolutely great. They're beautifully marked and they're a good gauge, which I love. You can usually stand them on their edge, which is the most satisfying thing to do ever. Anyway, well worth 15 pounds or whatever they are. Obviously, if you don't lend them to anybody. Okay, enough mucking about. We've got our mark. We know that our hole wants to be about 2 mil. That's all below that, so we can pop it on there. And it's time to punch a hole. So I did have this set up last week, and the hole was a bit big. So you want the hole in the spring here to be bigger than the hole in the top of the pendulum. And the problem is here, because this has been riveted and drilled out, that hole you can see there is pretty chunky already. So I don't quite know how that's going to work, because if the hole in the spring is smaller, the pin obviously jams in the spring and not on the pendulum. The whole thing's always unsatisfactory and wobbly. So I'm just going to have yet another experiment. So I've got my staking set, which I'm going to use to punch a hole, and I've got a stake. Just find a hole. Maybe that one. And I'm just going to punch some old random hole down here at the bottom. Punch it a little bit harder. It's always tricky when you're punching near the edge of the spring, because it tends to split if you go it. Don't think that's still punched through.
It says, can't you push the pendulum rod?
Could do, yeah. If you wanted to close up that hole, yeah, you could. Really good idea. You could get a bit of bushing wire and put a bush in there. True, good point. Right, let's just push that stuff out of that. Right, so that was a bit of a faff. So we've got our hole in, test hole here, test hole number 2. And let's just see if that's too small. I've got a feeling it is. Yeah, it's pretty much the same size as the hole in the rod. So when we put our pin through, yeah. So what's happening? You can't see this, but when I turn the spring, it's turning the pin. So that hole's too small. So I'm going to have to go for the next size up punch, or a next size up punch. That one. Okay, which is a bit of a shame because it's going to make the hole all a bit baggy. But Derek's point is really good. Actually, if I was spending more time on it, then you could just get a bit of bushing wire and plug up that hole and you'd be good to go. So I've gone up 2 sizes here. But to save us the torture of spending too long, let's just get that in the middle. Check that. What you could do actually, again, if you were spending a bit more time on this, is to get your odd leg dividers and make 2 marks, parallel marks from the edge of the spring to find the middle, and then that would give you an eye line for getting the punch in the middle. So there we go. Not too bad. Close enough. So just hammer that little burr down, and remember, like last week, we're going to deburr. Don't just leave it like that because there's still a burr there. So get your Arkansas stone. There it is. And let's just get the burr off that. Just to tidy it up. It's really sort of annoying when you take a spring out and the end's all kind of curled over it. It's not pleasant. And this actually leads us to what we're going to be talking about next week, which is our top 22 faults that we find on clocks, again, to try and help people in fault solving. And one of them is the pendulum not swinging straight, in a clean arc. And you can get around so many of these problems by attention to detail when it comes to making the spring. So let's just have a look how much material actually goes in the slot. It's about the width of the spring, so that's about 1/4 inch. So we can safely break it off somewhere down there. Doesn't want to be too close to the hole because you don't want to lay awake in the middle of the night. I mean, not going to happen on a clock like this, maybe, but the pendulum's quite heavy, so don't cut the spring off right close to the bottom of the hole. I've left, as you can see there, about 4 mil, something like that. So a bit less than 1/4 inch. So let's break it off. You can put it in the jaws of a vice, but I'm just going to look for a pair of pliers. Question? Question? No? Oh, no question. Good. Might do the job.
Ruby says you definitely don't want a broken suspension spring if you've got a mercury bob regulator.
Exactly. And you're absolutely right. I've just starting, well, not quite gotten started yet even, but for an institution, they've got a regulator with a big old mercury pendulum. It's in a public space. So you've got to be super, super careful, because not that the mercury per se is like the biggest problem ever, but a spill is a big deal. And again, just break that off. There we go. So again, I'm going to tidy this up. So yeah, you want to avoid a mercury spill. I don't know what the situation's like in the States, but that hazardous substance comes under the jurisdiction of the fire brigade or the fire service. So just using my stone here to smooth off those corners. And so if there's a mercury spill and the fire brigade turn up, they will like close the room down, maybe close the building down, and the whole thing gets completely out of control. So don't have a mercury spill. In fact, if you work with clients or institutions that have got mercury barometers or mercury regulators, then my first bit of advice to them, just smoothing off the end of that spring there, is to get a mercury spill kit. Make sure your staff are trained in what to do with that spill kit. Sun's come out, which is great, but I'm going to have to go and close the blind, I think. That's okay, no, are you going? All right, okay. And yeah, it's enormous fuss. So yeah, get a mercury spill kit. There we are. So our suspension spring, let's just get it in focus, is done for the time being. We're just going to try it, make sure it actually fits in the slot. Can't really see. There we go. I think I've left it a bit too long. Annoying, left it too long. Okay. No, I'm not sure there'll be enough to snap off. Too much talking, not enough concentrating. Right. Story of my life. There we are, just about enough to break off the end. And again, let's just go back and stone it a bit. And if you've got one of those, actually, I do have one of those. Time. It's 37.
Yes.
Oh, I've got lots of time. Great. Okay, so I've got my ease lap, whatever it's called, and my super favorite flat nose pliers. No, they've gone walkabout. Those pliers have got legs. I think it's because they're new and they're still a bit feisty. They haven't.
Well, you just said they're in this one, remember?
They're inside. Oh yeah, I forgot. Yeah, they're inside this one. It's good because I'm going back next month to do a kind of curatorial training week. So when nobody's watching, I'll just kind of go, oh yeah, oh, I found my pliers. So I'm just going to use my diamond lap here, easy lap, to stone off the corners or to grind off the corners. Would be better if I had those pliers, but I don't. So it's always nice, again, if you just have a little bevel on there, like that. And the same on this side. Difficult to hold. There we go. Okay, right, we're getting there. Who would have thought it was that difficult? Let's just sanity check it. Pop that in there. Now that, remember, that top block is still too tight. It needs to just fall easily, but we'll deal with that in a minute. Right, we're good. Really good. Happy with that. Mustn't lose the rating thread. So just a couple of things here. I think what's nice, I might not do it on this because it's getting a little bit sort of close to the edge with it being quite a big hole. But on a spring like this, I'll do a drawing though, because I haven't done one this week. Let's just zoom out. So what you've got here, looking at the side, yeah, we've got our pendulum rod like that with a hole drilled through which the pin goes through, and we've got our spring coming down, sort of exaggerated it a bit, and there's your pin and there's your top block like that. And this is absolutely fine. This is, you know, if you buy one from the, do a bit of colouring in there, if you buy one from the material suppliers, this is what you're going to get. And it's kind of, it's perfectly fine, perfectly serviceable, but it's actually quite nice if you go into the trouble of making a spring to actually taper this a little bit here. Should put a dotted line, shouldn't I? By cutting it down like that, it just looks smarter. And it also, of course, it weakens the spring here a little bit. So it tends to focus the point at which the spring flexes down here. It's more of an aesthetic than anything else, but I usually would do that on a clock like this. So I've just, and we can do that a couple of ways. You could either trap this in the vise and again use your stone, a diamond hone thing, or you could actually chisel, or using a pair of tin snips like shears, arrow shears, you could actually cut the edge off it and stone it, and that would taper it down a little bit and make it look really smart. So I might, if I can just see the device. Again, these diamond hones, diamond lap things have been incredibly useful for this kind of operation. So I won't faff with it too much. So yeah, do you remember us chiseling a bit of metal months and months ago? I just got an old wood chisel, regular chisel, and I stoned the end to like a 30 to 45 degree point. So no good for chiseling wood, but actually really good for this kind of thing. So you can just and get rid of that excess material there. Works really well. Anyway, I won't do that because it's faffing about really. Well, maybe I'll do it. No, I can't, because once it's riveted together, we're committed. So, right, last thing then is to find our pin that I made, which is here, and rivet it together. So we are at the point of no going back. So let's take that steel pin out. I can remember which way it goes. That's the problem with making something a good fit, isn't it? It's like, I'm not bothered about holding it with my cutters, by the way, because I'm going to cut the ends off it. So, however, what I am bothered about is the fact that it's a really good fit. Should have marked which way round it went. Anyway, it just shows it's not going to drop out in the middle of the night, which is useful. So let's just rescue that before I lose it. So in with our brass pin. So this one's going to be riveted. Remember, when you're riveting, in horology anyway, that not maybe in industry, you don't typically need to countersink the head of the rivet in order to make it strong. You can leave it totally flush. And what happens is when you rivet it, it'll spread out enough to hold it in there. Like with pillars, if you're ever riveting a pillar into a plate and you're doing new making, you don't countersink or chamfer it. Otherwise, you'll always end up with a little circle there, which is annoying. So just do it kind of plain. Good. So let's just tap that in the hole. Again, we don't have to go crazy. That pin that I made is slightly tapered, and I broached the hole. In fact, I'm pretty sure I broached it from the other side. I remember now. That's why I put that little dot mark on there. So just change that around. Just going that way. Check we are still lined up, which is great. And then find our piercing saw. You can see, yeah. And well, let's just cut it off. I don't know, 1/2 mil, too long. As close as you kind of dare. But you need to leave a bit on there for riveting, obviously, otherwise it won't rivet in. And same on the other side.
Questions about pins.
Yeah.
Jane says, can you use brass taper pins for riveting?
Yeah. You can, if you've got a tapered pin, you need a tapered hole. So you need a brooch taper pin to fit in the tapered hole. Otherwise, at one side, I mean, actually, by the time you've riveted it, it'll fill the gap. But yeah, you can use brass taper pins. I find that brass wire you know, the kind of hard drawn brass wire that you can get from eBay, new old stock, is better. It just gives you a whole lot more flexibility. And in my old life, I used to do a lot of filing pins for things like repairing jewelry and watch bracelets. Just being able to file that really long taper just makes it grip, and especially if you draw file it. The problem with the pins is you can't kind of get hold of them so easily. So I would say get yourself an assortment of brass pin wire from, you know, retired estates and all that kind of thing.
Joseph asks, what's the best way to remove a pin that's broken in the hole with nothing of the pin left to grab? Right. Okay. Well, that's a tricky one. It's one that drives me crazy. The answer to that is, well, the question is, how do you get a pin out if it's broken? If it's on something like a slip washer on a long case, tall case clock, where they're often cut off by repairers, then you can sometimes shear the slip washer off. If it's mild steel pin or a brass pin, you can often shear it. That's easier said than you might, easier done than you might imagine. If you've got a steel pin in a brass hole, the problem is if you start to drill it, if that's your only option, obviously you try and figure out which way, because they're normally tapered, which way it's tapered. But if you start to drill it, the problem then is that the drill inevitably will wander off and want to drill into the brass. What you can do is use alum, which is a chemical that will actually rust away a steel pin in a brass hole. So if you've got a watch plate, for instance, got a broken screw, you can use alum, and that will corrode the steel and kind of crumble it away. But it's tricky, is the answer. Little center punch, find the center, try tap it out in both directions, but ultimately you might just be in for drilling it out. So that brings me to a much more, well, not a more important point, but my point, which I've made 10 times already, is that when you're fitting pins, don't rivet them in. They don't need to be riveted like this. Just push them through, not this one, but the one that holds it on the pendulum, and the next person can get it out, easy peasy. Okay, I'm just going to file the top of this pin here. Sorry, it's not focusing particularly well. It's just a little bit long, so I'll get myself a chemical you've just mentioned is alum. Yeah, I think Bergeon make a kind of proprietary brand of it, and I forget what they call it now. Vicin, is it called? Vicin, but it's alum. It's been used for centuries for rusting pins and screws. I think our Derek Alum told me about that last time, or reminded me. So I'm just going to using a bit of paper to protect the work, just file it down, and I want about 0.2 of a mil, something like that, to rivet, because you've already made the pin a really good fit in the hole. You totally don't need much, but obviously you don't want to file it completely flush either. I'll do the same on the other side. Great. Okay, I don't know whether you can see that, but it's filed down, so it's, I mean, it's more than 0.2 of a millimeter, but it's probably not half a millimeter anyway. So got our hammer here. This isn't particularly smooth there. So this is actually one of the few places I'd use abrasive paper to actually polish up the hammerhead before you start riveting, because whatever is on your hammerhead will end up on your work. I'll just use the Arkansas to get marks out of it, but you know, something micro mesh paper or something like that, or the 3Ms paper, just to get marks off there before we start to rivet it. So double check that the old thing's going to go through, and just rivet it. And yeah. Doesn't need crazy amounts of riveting. So again, my file's not super clean. Should be cleaner. But let's just file the head off that rivet now, and it should. So I'm just
you know, you could hold it on a bit of cork maybe, but the way to file this so it's dead flat is just to hold it on your fingers. And yeah, it files away a bit of your skin on your fingers, but as my old tutor said, it grows back. Let's just a little bit of a faff to hold. I remember we don't want to actually file it much thinner because it's nearly a kind of perfect fit in the back cork slot. Yeah, I might have to bring the old cork block out into service. This is just a bit too tricky to hold.
So it says if you're using alum, the solution needs to be saturated and better if it's a bit warm.
All right, okay, good. I've never actually used it, but in answer to that question, if you want to get a steel pin out of a brass hole, then that's one way of doing it. So excuse fingers. Let's just now check again so it wants to be able to assume the vertical position when the pendulum's on. It doesn't want to be sloppy, but it wants to be able to hang. If it doesn't hang straight down, this is one of the major faults we found with the Smith's clocks, is when they were made, the top block was often too tight. So people would regulate the clock, then the suspension spring will be sticking out at an angle, and then the timekeeping's all over the shop. So it's just a fraction too tight still on that pin. So I will just get the cork block. We've got time 51, yeah. Okay. So cork block, incredibly useful here because it just supports the work, but allows it to move. And of course, what we want ideally here is the grain running vertically along the work. So you can see we're getting there now. And that little rivet has effectively disappeared. Tiny mark, still a little bit more filing to go, but I just want to check it's not getting too slack. So yeah, it should be. And again, this sort of kind of faff is well worth it because it'll just mean that that is a nice, easy fit in there, but it's not wobbling. Okay. Let's get this back. Focus. Pop our pin back in, which needs shortening, but I can do that offline. Just double, triple check it. So there we are. There's our new spring. It's not wobbling in the thing, but it's just loose enough so the pendulum can assume that kind of vertical position. Right, so we want another pin here for our, I just wonder whether this, no, it's too small, the wire that we used before, which is a bit of a shame. So, and I don't think this hole is, oh, it is tapered. Okay, let's just have a look. Right, it is tapered, so we're okay there. Get the spring. I don't think it particularly has a left or right side. There's a little bit of corrosion on here, which I want to clean up. As I said, I think the spring had been soldered in and it had corroded. So let's get our pin. This is just one of the pins I yanked out of the false plate. Like that. Draw file it so it don't drop out. I'll put my gloves back on because I don't really have time. So again, checking. And you see, I've just pushed that pin in because it's draw filed and it's tapered in a tapered hole. It's already a really good fit. That is not going to drop out. We don't need to rivet it. Sorry, I know I've only mentioned that about 40 times tonight, but it's just so annoying. And inevitably, the minute you rivet it, you want to get it out again because you realize you've made a mistake or something. So all I'm going to do is give it the lightest of taps, like that. And then I'm going to do exactly the same thing as I did with the thing, the brass one. Get my piercing saw. This time I'm going to leave it about 2 mil. Too long. And here. And good to go. I've got to put some oil on it yet. And saw through your finger. Okay, thank you. Right, so there we are. So obviously those that pin needs tidying up. If you've got a watchmaker's lathe, take it out, tidy up the ends, or if you just do it in your pin vise. Again, I won't do it now because we're going to run out of time. I will just file the ends flat, otherwise I'll get whatever the word is, kicked out of that group. So there we go. So actually leave the ends long like that. It just makes the next person's job so much easier. You can't leave them long on a tall case clock because the pendulum block has got to pass up through the crutch. So you have to cut them flush, but again, don't rivet them. So we're done, I think. Just put that pin in there, other way around, like that. So offline, I've got 2 pins to shorten and tidy up now, but I'll do that and I'll stick it on Facebook. So let's just put our pendulum bob back on. And again, you can normally tell which is the front and the back because the slide will go through a lot further look on there when it's the correct way round. Remember, there's lead inside here, so if you're cleaning this, then just be careful of not breathing in the lead acetate that typically forms, or lead corrosion, and wear gloves as well. I've already cleaned it out. Okay then, so in the -3 minutes we've got, gloves back on, let's get this ticking.
Question? Sam says, is this the moment of magic?
It is the moment of magic, Sam. Yeah. Now it's time to click that Patreon button, if I had it, which I don't. I know Sam's going to be first in the queue, clawing at the Patreon button.
Wolfie says about the previous comment, don't lick that thing.
Don't lick the lead acetate, no. Jane was looking at a clock on for auction that had a kind of big clump of white lead acetate around the bottom. We talked about it on the live stream, didn't we, about evolved acids. So let's just very quickly, obviously I'm doing this rather hastily. However, just going to oil. So as always, oil above the pivot, then Gordon gravity will draw the oil down as well as capillary action. This Fusee back pivot's quite a big old bearing, so I'm going to put a couple of drops of oil on there. I'm using Mobius D3 here. Might use a bit of D5 later on that lower pivot, but it's fine. I've already done the barrel arbor pivots, escape wheel. Can't really see, but it's never stopped me before. Pallet arbor, again, up the top, really important. Don't put the oiler at the bottom of the pivot. I was looking at a YouTube video the other day, somebody oiling a clock and they went from the bottom and it just allows the oil to be dragged out of the hole. Okay, so we've done that. A little bit more on there. Not actually done any testing on this clock at all. So thank goodness we've got the old test stand. Where would we do without it? Bit of oil on the exit pallet. Doesn't matter which one you put it on, just put a little bit of oil on one pallet, and as the escapement runs, it will walk around. Don't put the oil on the escape wheel teeth because it'll just run into the roots of the teeth. Everything else is oiled. It's ticking. Nice. Ooh, come on, camera. Camera's very excited too, which is not a surprise. Don't blame it. Doesn't really need both back corkscrews, but since we've got them, we might as well use them. A little bit of camera readjustment. You'll see all sorts of horrors now, no doubt. There we go. There.
Joseph said, what oil of choice is better, synthetic or natural?
I go for the Mobius D series, which is actually a mix of natural and mineral. You can use synthetic. I don't get the point in clocks, certainly get the point in watches, although I'm not a watch repairer. And but yeah, I would just go for the Mobius D series. But any oil that's developed by a specialist clock oil manufacturer like Dr. Tilvish, another good breed, Mobius. Don't know of many others that actually don't just buy oil and stick it in things and write clock oil in the front. I wouldn't get one of those personally because it's not worth the economy. You know, your D series oils are about £30 now a bottle and they last a year, and you know, that's fine for me anyway. Okay, so it's wound fully or fully wound. That in there. Don't forget to put oil on. I haven't got any D5, the thicker oil poured out. So I'm going to use D3. So on the crutch, where it touches the slot, both sides, just to quieten it down a little bit. And look at that, perfectly in beat. I know how could it not be? Let's just have a little look down there. And let's just warm up our camera a bit again. Get some light in so you can see.
Oh, Jeremy says it's in beat because it's on the test stand.
How cool is that? Sorry, I'm squeezing in now between my camera and my test stand. It's in beat because it's in a test stand. Yeah, but I can assure you, Jeremy, that by close of business today, the test stand is only for your benefit. I went to all the trouble of making it just for you guys. It's going to be in the case on the wall. I'm going to stick it on Facebook. Maybe not tonight, but maybe tomorrow morning. But so there we are. There's a couple of things I can see. One is that the crutch pin is actually sticking up a little bit. It's not perpendicular to the frame. So I'm just going to bend that down. It's just an aesthetic, really. There we are. But other than that, let's just go on manual focus because it doesn't like it. There we are. Other than that, we're kind of good to go, really. Got a brush hair there. And be interesting to see whether this wobbling settles down. Obviously, if it doesn't, we'll have to investigate. But I think it will. Just give it a minute or two. Yeah, good. Yeah, settled down. So I'm perfectly happy with that. So there we are. So somebody, I think it was Debashish, quite a long time ago, asked about Fusee clock springs. We bought 2 Fusee clocks. One of them is still work in progress because it needs a weaker spring fitting. This one's got the 0.32 millimeter original or earlier spring. And as you can see, running sweetly as you like. A suspension spring was broken. We cleaned it. The pallets are a bit warm, but as you can see, it's a pity you probably can't hear it on the ticking, but we've tried that before and it didn't really work. Wolfie explained why it doesn't work. So thank you for that. So that's it. So that project comes to an end. I'll whack it on Facebook when I get it fixed up on the wall, and sort of very, very happy there. Hope it was of use. Thank you, as always, to Team Open Clock Club, who's been doing the typing here. And thank you to everybody who's come along for the ride. Next week, we start on the top 22 faults, fault finding, particularly for beginners. And we'll cover a lot of that ground. We've covered it before, but this is going to be kind of like condensed, you know, what do you do and what are the main faults we come across. So thank you very much. Glad to get our clock finished, and we will see you next week for our 42nd episode. Thanks very much. Bye for now. Oh, there's my mouse. I'll just mute it. Might as well just leave it ticking.